Hi everyone. All right, so what we're going to do today is we're going to talk about systems of linear and quadratic equations. So when we did systems of just linear, you would have two equations and we'd have to decide how we wanted to solve them so we could get a solution. All right, so now what we're going to do is we're going to introduce the quadratic portion. So with that, there are two ways to solve. Okay, you can use substitution or we can use graphing. Okay, so when we solve, we're still going to try to get roots, or not the roots, the intersections. So we're trying to find where these equations would intersect. Okay, so the first thing we're going to talk about is substitution. So if you remember from before, if you had an equation y equals the y or some letter was by itself, you could just plug in the other one. So here we have a linear, we have a quadratic, both of them are y equals, so we're going to take what y equals in linear and plug it into the y equals for the quadratic. So 2x minus 4 equals x squared minus 4x plus 1. And then we're going to move everything over and try to solve. So we're going to subtract and add. So now we have x squared minus 6x plus 5, and this whole thing equals 0. So we're solving, okay, solving. So do we have a GCF? We do not. We can just straight factor here, or attempt to factor. So I know my first term has to be x, and I have to multiply it to positive 5 and add to a negative 6, so I know I have to have a minus and a minus. And then factors of 5 are 5 and 1. So when I check this, I should have minus 5x minus 1x, which gives me a negative 6x, which is what I want. So when I separate, like we've learned how to do, okay, so this is the one difference of finding roots versus finding the intersection. We're still going to see where we're still going to solve for x. So this means there is an intersection at x equals 5 and x equals 1. So what we're going to do is we're going to plug in and see where that intersection is. So I'm going to take my first equation, like we've learned how to do. I'm going to take it and I'm going to plug in my first x value and get the first y value. So 2 times 5 is 10. 10 minus 4 is 6. So I have an intersection at 5, 6. And I'm going to do the same thing. 2 times 1 minus 4. So y, 2 minus 4 is negative 2. So then I have another intersection at 1, negative 2. And we can confirm this by looking at our graph as well. So we're going to plug this information in to our calculator. So take a minute and do that. So if you are at your calculator, that means your graph should look like this once you hit graph. And I do see that I have those intersections of 1, negative 2, and then 5, 6. And we're going to learn how to find those in a second. So with substitution, I want to do one more round of it. All right, so one more example. Okay, I have y equals for both these two. So I'm going to take what my y equals here for my linear, and I'm going to plug it into the y for my quadratic. So negative x plus 5 equals negative x squared minus 4x plus 5. Okay, so this is going to seem like a lot, but I want to make my a positive because it is a lot of work to factor with a negative up there. So I'm just going to subtract everything on this left side and move it to the, or on the right side and move it to the left side. So I've got x squared. I'm adding 4x to negative x, which is a plus 3x. And then I'm subtracting 5, which means that I don't have a 5 there anymore. So now this is equal to 0. Okay, this cancels. So now I can try to factor. I need to ask myself, do I have a GCF? And I do. I have a GCF of x. So now I have, on the inside, I have x plus 3 equals 0. So you would still split. So x equals 0, because if you plug in 0 for x, that does give you a 0. And then x plus 3 equals 0. So this equals x equals -3. So you should have an intersection at those two points. So we're going to plug it in. So -0 plus 5, and we should have y equals negative, so the opposite of -3. So we should have one point at 0, 5, and then another point at y equals 8, so -3, 8. So those would be your answers. You have two intersections, one at 0, 5, and one at -3, 8. So I want to jump down and take a look at what kind of graphing you could have. So for graphing, you have three scenarios. The first scenario is when you have a parabola and your line, and they intersect twice. So you have two intersections. Okay, so that means you're going to have two coordinates, so two xy points. Okay, the second scenario is when you have the line hitting your parabola once, so you have one intersection. And if you remember, the whole point of doing this is you're finding solutions for the system. So that means you have one of them, you'll have two solutions, you'll have one solution, and then for the last one, if you have no intersections, that means you have no solutions. Okay, so the whole point of doing this is to make sure that you're finding the solutions to the problem. So, for like the first one, for number 3, we're gonna take the time, we're gonna graph it, and then I'll show you how to do it in a calculator. So for this first one, I'm gonna graph it in green. So our linear, -2x minus 3. I'm gonna go to my -3 on my y-axis because that's my y-intercept, and then I'm gonna go down to the right one. And remember, you can do the opposite. You can go up to the left one, so you have more points to graph. Okay? So the linear is a little easier because it's just counting. Okay, so that's my linear equation. So then I'm going to do my quadratic in orange. And we're going to find your vertex. So your axis of symmetry, x equals opposite b over 2 times a. And this is stuff you need to know. This is not on your reference sheet, so you need to know it. So that means my axis of symmetry goes through -1. And then when I plug that number in to get my y value, because this gives us our vertex, the -1 squared plus 4 times -1 minus 3. So this should be +2, -4 minus 3 means our y value should be -5. So that's where my vertex is. So -1, 1, 2, 3, 4, 5. Okay, and then we're going to make a quick table of values to graph a parabola. So if I know my vertex and my axis of symmetry are going through this -1, I can choose points on either side of it. So I'm going to choose -3, -2, I've got -1, 0, and 2. So I know what -1 is. It's -1, -5. And I should hopefully remember that I have my x equals 0 because that's just your y-intercept, which is in your problem, it's -3. Right, so this should cross at -3. And so it looks like we already have one intersection. But when I plug in my numbers, we need to see what we're going to get. So take the time to do that now. So -3 squared is 9. Okay, so that's first one is 18. So then 4 times -3 minus 3. So this is -12 minus 3. Should that be +5? Or +3, sorry. +3. +3. Okay. So then we do the same thing with -2. We plug that in. So 4 This will give us a -3. So now it's starting to look a little symmetrical. So -2, -3. And then if we plug in 2, hopefully we'll get a +3. So we get 2, that's 8. So Mrs. Conine made a mistake. So change this, instead of it being 0, 2, make that a 0, 1, and then plug that in. I don't know what I'm thinking this morning. So when we plug that in, we should get 2 plus 4, which is 6, minus 3, which gives us our +3. So it is symmetrical. You're probably sitting there going, Mrs. Conine, yelling into the computer or your phone, going, that's not right. If we were in class, you would tell me the same thing. So I'm going to plot my points. And then I can make my graph, which I'm doing an awesome job of this morning. Make sure you count it correctly. I'm going to erase my axis of symmetry so we don't get confused here. And I just erased a whole bunch of stuff, guys. There we go. So we've got a whole lot happening. My computer's having a meltdown. Okay, so it looks like we have two intersections. We've got an intersection right here, and we've got an intersection right here. So our first intersection is at 1, 2, 3, -3, +3, and our other intersection is actually the y-intercept of 0, -3. And that would be your answer. Okay, so we're going to take this same equations and we're going to plug them into our calculator and graph them. So go ahead and go to your calculator. You should have -2x minus 3 and 2x squared plus 4x minus 3. Those should be the two equations that we have. So pause the video so you can do that. I'm going to go ahead and hit graph. So we've got our graph, and it should look similar to the picture that we have. So now to find your intersections, we're going to go to second, trace, and you're going to go down to intersection, which is number 5. And it's going to ask for your first curve. So your first curve is the first equation you plugged in. It wants you to get as close to the intersection as possible along that line. So once you do that, you hit enter. And same thing with the second one. It shouldn't move. It should just be right there. So you're going to hit enter basically a total of 3 times. So our first intersection we do get is -3, +3. That's how you would do the first one. So again, we're going to do it in the calculator to find our second one. So hit second, trace, intersect, or the number 5. So we're going to scroll back down along our first curve, which is our blue line here, and get as close to the intersection as possible. And we're going to hit enter 3 times, and we should have an intersection of 0, -3, which is exactly what we said we got when we did it by hand. Okay, so remember, you're going to do second, trace, and you're going to do the number 5 intersection. And then you're just going to follow your instructions from there. All right, so if you have any questions, bring them to office hours. You're going to do the same thing with if you have 2 quadratics. You're going to do the same idea. You can graph them or you can substitute, okay, just like we did. So make sure you're following what the equation said. Get them to y equals like 6. You need to make sure you're maneuvering a little bit, but you can graph or you can substitute. So I did provide graphs for you, but it's the same idea. Okay, 2 quadratics, or if you have a linear and a quadratic. But if you have any questions, bring them to office hours. Other than that, you have a great day.